I am from Continental and will present one of the project that we have in our production plant, face recognition for production plant. So uh, go through. As Continental is the vision zero, so we have this vision where we want to have zero fatalities, zero injuries, zero crashes from any of the our product. And in line with, we want to make sure in our product whatever we deliver, it is compliant with all the things, all the aspects. So to consider it, we actually develop a system um, for the plant. Generally, the process of part inspection in the shop floor comes into like only certified operator can inspect the parts in the shop floor. And for those certified operator, we have supervisors who manually assigned and authorized to assign these operator to the specific machine to operate and to verify the parts. So what are the we face some challenges there, why the solution is required in the plant. We seen like the supervisor assigned the certified operator to the machine, but somehow it been done by some other person, like some helper, maybe taking some time, and then they try to make it. So to make a process foolproof, where we need to have only certified operator which is being certified, trained for a certain job, should only operate to the machine. So to consider it, to face these challenges, we come up with this face recognition system. And the solution we developed based on the AI, where we have trained operators faces to the system, and then we have then only the operator allowed, the system allowed the machine to operate. And for this process, we have come up with the system, which is where we are checking the spoof check. If there is any spoof, we tried with the person, or something, if it is a real person or fake person, in the distance of 1 meter, because we want to have the person near to the machine, so that it should actually recognize the certified operator from there. So in this way, we used deep neural networks, which is keeping all the features in the database of the operators. And if I go next phase, where how we do it, first we enroll the our certified operator to the system. And then once the person is enrolled by the supervisor at one time activity, then then in the deployment phase, we actually have all the features which has been trained in the centralized location. We have in a cloud server where we keep all the certified operators um, uh, features which is used to which is extracted from the neural network. And how the system is being developed, we actually develop very low cost solution by using edge device into the plant, where we connected a camera, and that camera is actually located in front of the face. So when we see how this process works, the system flow works. So normally when the operator try to press the button for the circuit board, PCs is actually the circuit boards which is required to verify with the these experts. So when this is, it's, as you see in the first screen, where first image, where the operator is trying to press the button, but the operator is still not verified from the machine, from the system. So this particular part will not move as a verified, and it will wait to the operator verified, authorized by the system. And then once this authorization done, then there will be a feedback loop in the way of LED light, the green LED light, which will indicate now you are get approved. And then when the operator will press the button, so then only this particular part will goes to verification phase. And this system is easily maintainable. We have a very user interface, a friendly user interface, which has been developed. We also having like this solution as we develop initially for first one plant, but it is also implemented to multiple plant, multiple machines, and the reports are live available from the dashboard with the each part information, who process it, and then how it is been developed. So I'll move to next slide. And the feedback loop, as I mentioned, when there are a certain feedback loops which is has to verify within 1 second. So we have certain LED light which will actually indicate respective errors or respective feedback. As this we have in the production line machine, we have around 100 certified operator. So we got very good accuracy in the sense of the system we have implemented, as the system is in the stable lighting condition. So we had not got any issue with respect to lighting challenges. And all the logs with respect to part, and then what time the operator started certifying and other things is being recorded into the database. So why we needed it? Because it is having certain vigilance impacted with respect, if I take in the different dimensions. So first one is operation efficiency, where we improve the operation efficiency by not now supervisor is not required to assign certain operator to do the certain activities. So it is something the system automatically take care. We also able to reduce the human errors which is caused in the product, and product required re-verification previously. So that also we have minimized. We actually come up with annual cost saving till 2027 is around 2 million per plant, as Continental have multiple plants. So we see a huge benefit from this small solution. And apart from this, the value creation for the customer, where we will have we are preventing the defect in the products. That is one thing which is actually improved a lot. And then when we have implemented this process, now our customer is more reliable. Like this is something, the process being used in the plant is AI enabled, and which is actually more reliable with respect to having only certified operators actually verified in an expert is verified the product. That means that this is the reliable product. Safety perspective, we also we also able to reduce the operational hazard, because if someone who the helper comes to do that activity, then this is something also been we can reduce any injuries happen. So these are some of the business impact we identified. Apart from this, social impact, um, because when we have when there is a number of product need to work, right? If there is one or two product get maybe rejected because of certain process things, then we have to again reproduce that, and it is also coming up a lot of I would say lot of things comes. So that way I feel like this is something which is also help us to reduce the carbon emission in the process. Reusable of multiple locations, because the same system can be reused, and as we have deployed it into AWS cloud, where the locations, or I would say reports, can be visible. So it can be seen, like all the plants data can be seen from the one location, and it is as the solution is reusable, which can be deployed in the multiple machines. It is also, as I mentioned
Mr.
previously,
Nahar,
also.
your
Yeah.
time is up, sir. Your time is up.
Okay.
I believe you were closing the slide as well.
Yes, yes. This is
Yeah,
the closing slide.
yeah.
Yeah.
Okay.
So
No
reduce.
worries.
It is
So,
also
so
reduced.
the time
Hmm.
is up. We would close the
Okay.
presentation, sir. Okay,
Sure.
let's
Sure.
start
Okay.
with
Fine.
the Q&A first.
Thank you.
Any of the children would like to go first? Yeah, Professor Shrikant.
Hi, this is a very nice application. I'm sure it has made a big difference to your plant. So one of the questions I had is, what happens when your system detects that there is a unauthorized person,
So
right?
basically, yes, sir. So this will not allow the unauthorized person to operate on the machine because,
Correct.
as you've seen in maybe one of the slide, I showed the process.
No, that
So,
part I
so
understood.
yeah.
But my
So,
point is that
mm,
that will stall your production. And how will you recover from that? I mean, it might be a mistake from the deployed system. It is looking at an authorized person, but maybe he
mhm,
grew a beard
mhm,
or he forgot to shave,
mhm,
and your system decided he is no longer authorized.
mhm.
So, how do you recover from that kind of mistaken identities?
Okay. So I think with respect to little changes, if it is too much beard, then I think there is already challenges we've seen where it was rejecting the person and then supervisor has to register again the person. But in the minor changes or having very minimal changes, it will not impact anything. Only if
Mhm.
there is a sudden changes in the face, if there is a too much beard, the person came after 15 days and then there is a lot of weird it happened, then it has to re-register. So that is something
Mhm.
we have to take care because we don't want to allow like if there is a delay, definitely it will not be more than 1 or 2, I would say, minute, because this is a very quick process where the
Okay.
person just need to
And
come in
you
front
have
of.
not seen your system going wrong at any point in time?
No, we haven't seen because lighting conditions and everything is stable in the plant. So
Okay.
mainly most of the challenges I feel when I was developing in my lab or in my desk. So that time the lighting condition change, and then if I here and there or my background or all other things changes, then there were some challenges.
Hmm.
But in this environment, I haven't seen any challenge.
Okay. Okay.
Yes.
Thank you.
Thank you, Professor. With
Yeah,
respect,
hi.
yeah,
Yeah,
Dr. Asad.
hi. Yeah, yeah. So yeah, it's a nice presentation. So I have one questions regarding your model, right? You said
Yes,
that
sir.
you have a neural network in between, right? So what kind of neural network you are using for this?
So basically, we have optimized ResNet. We have not taken all the layer like ResNet 15
Mhm.
layer. We have only 12 layers which we have retrained the model, and then we have refined this model. And we also not like we are just getting the features, and we are storing those features, each person's feature into a database, and then we are matching those features. We are not classifying the person here.
So classifying the person means what? So
So basically, there is a classification approach also where we see in some
uh,
face recognition where 4 or 5 people have trained, and then we just need to recognize those person. But this approach is something like based on feature matching. So we have extracted the feature from ResNet, and then we have stored in the database. Now our cosine similarity algorithm will try to similarize the features distance, and based on that we are actually evaluating the uh, system.
okay. So you have not fine-tuned any layer of resonate with your own data, right? That you have not done.
No, sir. We actually optimize the network. Like we have created only 12 layers. We have reduced the layers because we don't want much time to in the feature extraction phase. So we have optimized these ResNet feature. I would say layers, and we are extracting only features from that. We are not hiding actually any layer. So kind of transfer learning we are not applying here in other way.
Or transfer learning you have not done. Okay.
No,
Okay.
sir.
One thing, and another question is you talked about carbon emission, right? You have
Mhm.
reduced the carbon emission. So what was the computational overhead in your model?
So basically, carbon emission in other way also. Suppose we have produced a product and which is not maybe a correct and which require re-verification. That means
Okay.
the light used for that particular plant or reoperating the machine, and there are many things comes into picture. So that way, I am telling like the carbon emission will be is getting reduced because of not re-verification. And even like we are not using supervisor, which is again one of the additional thing, right? Whether there we need additional person who has to take care of it, and then there are many factor comes into the picture when the person will be operated as a additional person. So that way there are many things we considered.
So this this ResNet part, the model part, neural network part, have you evaluated that how robust is the model, how good is the model, and
Sir,
what are the parameters you had used? Yeah.
yes, sir. As we have only 100 operators in one plant, like
Okay.
those are actually operating, so we don't have a huge number of phases where we may that may create a complexity. So in this way we have this limited number of people and accordingly having a feature extraction for those people. So that means there is no challenge we have found with respect to maybe misclassification or misidentification of the person. So it is a very robust system for this particular data
And
set.
it can be scaled up for, let's say, 1,000 people, 20,000 people, right? That is what you
That
are
we need
saying.
to see actually. As of now, we have done rescaling for the multiple plants because we have plant in Bangalore, we have plant in Manesar, we have plant in other locations also. So that way we have deployed the system. But each plant has there is not more than 100 operator certified people expert for certain job. So that way we are safe as of now. But as
Okay.
for your question, for 1,000 people, definitely this system may not work as expected. So we have to work for that level of complexity.
So you have to rework again on your modeling part from the very scratch, or
Modeling,
you
because
can.
see, yes, because now the problem statement is very different because my
uh,
feature extraction will not take more than more than milliseconds. If I increase the number, then the this detection or recognition will take more time. That means I have to think a different way of implementing this system.
Okay, thank you. Yes.
All right. Thank you for the nice presentation. I have two quick questions. When you talk about the various sectoral areas, if you talk about the societal impact, can you tell me about the various sectoral areas where this will be applicable?
Yes, ma'am. So this will be applicable. The first thing is social impact.
Uh,
As we
Ma'am,
mentioned, carbon.
you might be on mute, ma'am, because there is a disturbance of ringing from your end. Yeah, thank you. Yes, Mr. Nath, you can continue the
Yes, ma'am.
question.
So basically, there will be many social impacts. So first impact is something like if I want to reduce the carbon emission, then first thing is the supervisor aspect who need to take care of the person because that is an additional person who need to do the supervision. So he need to use vehicle, he has to utilize the things, and then he just need to do the supervision activity. If I use the AI, that will actually help me to reduce that person, right? And that person can do some any useful job, anything which where the intelligence, human intelligence require, because this is the very repetitive thing. And here I see like AI can do better because it is very I would say um, very
I would
foolproof. And
like
Mhm.
to put my question very specifically. I would like to ask which sectors or which type of industries are more, your target customers.
Okay, so for me as of now this is an in-house solution, ma'am. and based on in-house solution, it is impacting the product which we are actually developing. And those product, if there's those product mostly goes to automotive, right? And automotive is linked to multiple, I would say, sectors, right, where it is getting benefit, either transportation side or having all this industry 4.0. So many sectors can be benefited from this solution.
Okay, all right.
Yes, ma'am.
What
Thank
is
you,
the
ma'am.
innovation in this? Because facial recognitions are pretty old systems.
Yes.
Yeah.
The world has moved pretty far. Okay, it is a good use case for yourself.
Yes,
Very
sir. Only
quickly,
that's
because
what I
very
mentioned.
good.
This is very small use case, but impact is huge. If I see.
Okay, thank you. Thank you so much.
Thank you, Nar. Thank you for your time and wish you the best with your innovation. Nar, we are
Thank you.
sharing a link in your chat box. Please do copy the link. This link is a self-assessment link. And Nar, if you would like to wait for 10 minutes, there are observers in this meeting as well who would like to ask you certain questions related to your innovation. They can mention to you in the chat box. Please wait for 10 minutes and do copy the link and enjoy the session.
Okay.
Thank you.
Thank you, sir.